Hello, ladies and gentlemen. Today we're going to talk about inverse trig functions and how they work with your regular trig functions to help you solve right triangles. You're going to need a calculator. You definitely need a calculator here, a pen or a pencil, something to write with, your notebook, and the foldable. So let's get started. Okay, let's think back. What are inverse functions? So if we think about functions like in the picture, that function machine, what does it mean to be an inverse of a function? Okay, so in our typical machine, a domain, so your domain value, your x values, gets plugged into the function. It goes through the function, you do your manipulations, and it comes out with a y value. All right, so when we have our trig functions, we inputted that theta, or that angle measurement. This is just an angle. Okay, we plugged it into our trig function, the corresponding one, and we came out with a ratio or side length, okay, the ratio of lengths. So how is this going to work then for an inverse function? So think about inverse and what inverse means. Inverse is just the opposite. So instead of inputting an angle, we're going to input the ratio and come back with an angle. So both of these machines are going to work backwards. So an inverse plugs in the y value and tells you what you get for your x value. So let's see how this looks when we're dealing with trig functions. All right, so we're going to have three main sine or inverse trig functions. The first one's going to be a sine inverse, the second one's going to be cosine inverse, and the third one's going to be tan inverse. So again, you're still going to focus on the SOHCAHTOA. SOHCAHTOA is still going to aid us in solving these problems. But instead of using SOHCAHTOA directly, because SOHCAHTOA would help us find different side lengths. So again, if we're doing the opposite of finding side lengths, that must mean that when I'm using sine inverse, I'm finding angles. I'm trying to find an angle. Same thing, if I'm using cosine inverse, again, this inverse means I'm finding an angle. Again, with sine or tangent inverse, again, that inverse means I'm finding angles. So we're going to use these inverse functions when I want to find angles. So that's really important to understand. We use regular trig when I'm finding side lengths. We use inverse trig when I want to find angles. That might be something you want to memorize so that way when we start these problems, it comes quick to you. Regular trig's for side lengths, inverse trig is for angles. Okay, so let's again remember SOHCAHTOA, okay, what those mean for us. So sine inverse, if you flip open your foldable, sine inverse again means opposite over hypotenuse. So opposite of angle A would be side length A, and the hypotenuse is C. So A over C would be that ratio. Again, for sine of B, opposite of angle B would be side length B, and the hypotenuse again is C. So it would be B over C. So we're still going to use these ratios to help us solve sine inverse, but it's going to look a little bit different when we're solving. Similar ratios, different way to solve. And we'll talk about that a little bit more, but let's remember cosine then. So the K in SOHCAHTOA means adjacent over hypotenuse. So if we're looking at A, cosine of A, adjacent, which means touching, would be side length B over hypotenuse, which is C. So B over C would be the cosine of A. Okay, again, if we're doing cosine of B, adjacent, which means touching, would be A, and hypotenuse would be C. So that one would be A over C. And lastly, for tangent, okay, with tangent of A, this is my angle A, so tangent would be opposite, which is A, over adjacent, which would be side length B. And then tangent of B would be opposite, which is side length B, over adjacent, which is side length A. So again, if you notice, the tangent of your angles are just flipped. So tan A would be A over B, and tan of B would be B over A. Okay, so again, we're going to have to use these ratios to help us solve these angles, but we're going to have to use sine inverse, cosine inverse, and tangent inverse. So let's take a look at what that actually looks like for given problems. All right, if we go back to our sine inverse flap, we should have two different examples. The first example here on the left, again, remember our inverse, this means I'm trying to find an angle. So right now the unknown in this triangle is this x, this angle. Okay, and the side lengths that I'm given. So notice we're given the 12, which would be opposite of the angle I'm talking about. and 17, which would be the hypotenuse. So I have opposite and I have hypotenuse. So if we think back to SOHCAHTOA, which one of these deals with opposite and hypotenuse? Hopefully you'd be thinking sine, because we are on that sine inverse tab. So we know that we're going to deal with sine. Okay, so I know I'm dealing with sine. So sine, then, we always put in the bubble, we're going to put that angle, but here my angle is unknown, so I'm going to put in x. Okay, so sine equals opposite over hypotenuse. So the opposite of my angle x would be 12, and the hypotenuse is 17. So this should look pretty similar to the way we've been setting up our trig ratios. But now, again, we're trying to solve for that angle. So the angle right now is inside that parentheses. So my goal is to get it outside of the parentheses. I'm trying to solve for x. So you'd think I have to do the inverse operation of sine. Well, obviously that's going to be our sine inverse, but what does that even mean? How do I do the inverse? Well, if you think about multiplication and division, the inverse operation for multiplication, inverse, is division. So when we talk about our trig ratios, the inverse operation of sine, inverse operation for sine, is going to be sine inverse. So what we do on both sides here, and I'll change up my colors so we can see this pretty clearly. What we do to both sides, we're going to multiply both sides by inverse sine. So both sides, because what we do to one side, we got to do the other. So inverse sine on both sides. What's going to happen on my left-hand side is the signs are going to cancel out. I'm just going to be left with an x. Over here, I'm left with sine inverse of 12 over 17. So now this is where we pull out those handy-dandy calculators and we type this in. So how are we going to get the inverse button? If you look at your button that says sine or sin on the calculator, right above it should say sine inverse. So in order to get that button on top there, you're going to have to hit the second button first, or that other colored button on your calculator. So what you would type into your calculator then would be second. Do this with me. Then you're going to hit the sine button, so the one that has sine inverse on top. Okay. Next thing you're going to hit is the number 1. Then you're going to hit the number 2. Then you're going to hit your division button. Then you're going to hit number 1, and then you're going to hit number 7. So all I did was type in 12 divided by 7. After I got the second sine inverse, I type in 12 divided by 17. Okay, now you type that into your calculator and you should get a number back. And the number that you get back should be approximately, I'm going to do my approximately, 44.9. Okay, and I'm going to cut it off there, and I'm going to stop there at degrees because I was finding an angle measure. Now, if you're not getting 44.9, your calculator might be in a different mode. Our calculators have two different modes. We have radians and we have degrees. So if you're not getting back to 44.9 degrees, you're going to want to talk to me in class, and we're going to have to switch that. So your calculator might be in radians. If you don't get 44.9, your calculator is definitely in radians. Okay, so when you get to class, I'll fix that for you, or if you know how to fix it, you can just go to the mode on your calculator and change it from radians to degrees. There should be a mode button on your calculator if you want to try fixing it on your own. If you just want me to fix it in class, that's fine too. Let's just follow along with this next example then. Okay, so again, let's look at this next example. Okay, I'm trying to find x here. So I'm trying to find an angle. That means I'm using sine inverse. Or I could use cosine inverse or tangent inverse. Let's figure out what we have. 3. The side 3 is opposite, and the side 7 would be my hypotenuse. So again, I'm using opposite and hypotenuse, so that's going to be this sine. So we're going to set it up again the same way we set up all of our trig functions. Sine of an angle. What goes in the bubble? The angle doesn't. Right now, we don't know the angle, so I'm going to put an x. Opposite would be 3. Hypotenuse would be 7. So again, we want to get that sine away. We want to solve for x, get x alone. So we're going to multiply both sides by sine inverse, the inverse of my function sine. So sine inverse, and I put that kind of out front so I know when I'm solving here. So those signs are going to cancel. I'm going to be left with x equals sine inverse of 3 over 7. Okay, so again, once we get that x alone, this becomes a calculator problem, and we just plug this into our calculator. sine inverse, so second sine, and then we type in 3 divided by 7, and your calculator should give you back the number 25.4 degrees. So that would be approximately what my angle measure would be there. So again, if you're having problems typing in your calculator, that's fine. Hopefully we can get to the point of where we need to type in the calculator, and then we can address that issue in class. All right, so now we jump to cosine inverse. So again, since it's an inverse, that means I'm going to try and find angles. So here in my first example, that x, my unknown variable, is an angle, so I should be using an inverse. If we look at what we're given in this triangle, we're given the adjacent side, and we're also given the hypotenuse. So adjacent and hypotenuse means we're going to use adjacent and hypotenuse, so that would be cosine. So we're going to start by setting up cosine. Okay, we put our angle in the bubble, so my angle is unknown, so I'm going to put it with an x. And then adjacent would be 5, hypotenuse is 9. So similarly to sine inverse, we got to get rid of cosine. So the inverse operation of cosine is going to be cosine inverse. So again, we multiply both sides by the inverse. So on the left-hand side, the cosines will cancel out. I'm going to be left with just an x. On the right-hand side, I have cosine inverse of 5 over 9. Okay, now once we get to this point, my x is standing alone, so that means this is a calculator problem. So we're going to plug in cosine inverse. Okay, this should be above the cosine button. Right above cosine should say cosine inverse, so you use your second button to get there as well. Okay, so then we type that in, and it should come back to be approximately 56.3 degrees. So when you type that into your calculator, this is what that x value becomes. Okay, I'm going to have you try the second example for class and see if you can just set it up by yourself. If you don't have a calculator, just get to the point where x is standing alone, and see if you can get the solution back to be 58.2. See if you can set it up and get that solution back. And I'll check that when we get to class. All right, and our last two examples for the day here, we're going to start again. We're finding x, and x is an angle, so that means I better be using an inverse operation. So what am I given here? It looks like I'm given the side that is opposite, and I'm also given the side that is adjacent. So if we remember back to SOHCAHTOA, again, you're going to want to remember that, SOHCAHTOA. Okay, the one that deals with opposite and adjacent would be tangent. So we're going to start by writing out tangent. I got to fill in my angle, and my angle here is unknown, so I fill in it with an x. Okay, opposite then would be 5 over adjacent, which is 12. So again, we're trying to find an angle, so we are going to use our inverse operation. So inverse of tan would be tangent inverse. So we got to do that to both sides. Tan inverse. On the left-hand side, those cancel out. You're left with just x. On the right-hand side, I have tan inverse of 5 over 12. Again, once you get to this point, we're going to just type it into our calculator, and after you type it into your calculator, give you a second, type that into your calculator, you should get back the answer of 22.6 degrees. Okay, if you're not getting that back, either you typed it in wrong or your calculator could still be in radians. If you don't know how to change it to degrees, that's fine. We'll talk about it in class. Make sure you ask me in class so we can get that fixed so you can do your homework problems correctly. Our last example of the day then, here again we're finding an angle, and again we're given opposite and adjacent, so we're going to be using tangent. So tangent of the angle, we don't know the angle, so I put in the x, that's what I'm trying to find. Opposite is 9, adjacent is 2. So if we want to solve this problem then, again we got to do the inverse operation. So the inverse operation of tangent would be tan inverse, so I'm going to do a tan inverse to both sides. Okay, so then on the left-hand side, those are going to cancel out. I'm going to be left with x equals tan inverse of 9 over 2. So again, type that into your calculator and take a moment to type that into your calculator. I'm actually going to have you type this one in your calculator, and I'm going to check this example as well. The answer you should get here, I'm not going to tell you, but I'm going to see if you can type that in your calculator. Again, if you have your calculator in radians and you don't know how to change it to degrees, that's fine. At least get it set up, and we can talk about this example and your cosine example when we get to class. Again, I want to thank you for taking good notes. Make sure you jotted down any questions you might have, anything that's confusing, so we can address those issues when I see you. So I will see you when I see you. Thank you for taking good notes.